Friends, now today we are going to see the examples on parametric curve. Okay, so very first we are going to see the algorithm to trace the curve and followed by the examples. Okay, so while tracing the parametric curve, first of all we are going to see how the parametric curve look like. So the equation of the parametric curve is look like x is equal to f of t and y is equal to g of t, where x and y both are depending on the parameter t. So that parameter may be anything. Okay, here we are taking the parameter as t. So x and y both are the functions of the parameter t. Okay. Then the next step that we are going to see is the limitations of the curve. Now limitations of the curve means what? We are going to find out the greatest and the lowest values of x and y for some proper values of t. That means basically we are going to find out the maxima and minima for x and y both for values of t. Okay. Then next to that we are going to check out the symmetry of the parametric curve. So the curve will be symmetric about x-axis if that ft function is even and gt function is odd. Now I hope that you remember what is even and odd function. If you replace t by minus t and f of minus t is equal to f of t, then ft will be even. And if f of minus t is equal to minus of f of t, then ft will be odd. So we are going to check out whether your function ft is even or odd. If ft is even and gt is odd, then the symmetry is about x-axis. On the other hand, if your ft is odd and your gt is even, then we are going to say that the curve is symmetric about y-axis. Okay. One more thing that we are going to check out, that if we replace t by pi minus t and y remains unchanged, that means y will be same as it is, and x has a equal and opposite values, then also we are going to say that the curve will be symmetric about y-axis. Okay. So let us go to the next point. The next point is very important, where we are going to check out the whether the curve is passing through origin or not. Now how to check the whether curve is passing through origin or not? So we have to find out some values of t for which x and y both will be equal to 0. Okay. So for the same value of t, we have to find out at the same time x will be also equal to 0 and y will be also equal to 0. If such kind of t you will get, then only the curve is passing through origin. If you can't find out this kind of t, then the curve is not passing through origin. Okay. Now the next point is the spatial point. So we are going to find out the points x and y for values of t at which dy by dx is either 0 or infinity. Now here, while finding out dy by dx, we are going to make use of the formula dy by dx is equal to dy by dt upon dx by dt, because y is not directly depending on x. X and y both are depending on the parameter t. Okay. Therefore, while finding out dy by dx, it is equal to dy by dt upon dx by dt. Okay. Now to find out this values of x and y, we are going to make use of this table. So we are going to find out such values of t, okay, for which x and y will give you dy by dx is equal to either 0 or infinity. Okay. So with the help of all these points, we will try to trace parametric curves. Okay. So look at this problem. The problem is x is equal to a into t plus sin t and y is equal to a into 1 minus cos t. So here x and y both are depending on the parameter t. Remember that t is a free variable, it can take any value. Okay. Now one by one we'll check out all the points and we'll try to trace the curve. Okay. So the first thing is we are going to check out the limitations of the curve. So if you put here cos t is equal to plus 1, you are going to get y is equal to 0, and when you put cos t is equal to minus 1, you are going to get y is equal to 2a. Now why we are putting cos t is equal to plus 1 and minus 1? Because we know that this is the maximum value of cos t that it can take, either plus 1 or minus 1, because the graph of the cos is always lies between plus 1 to minus 1 to plus 1. Okay, so the maximum and the minimum value of cos, that we are going to take it as plus 1 and minus 1, and corresponds to that we are going to get y is equal to 0 and 2a. So we can say these are the maximum values of y, maximum and minimum values of y. So minimum value will be 0 and the maximum value will be 2a. Similarly, if you look at x, so here your x is equal to a into t plus sine t. Now here again this sine t will take the value maximum plus or minus 1, but this t is free, it can take any value, so there will be no restrictions, no limitations on x. X can take any value between minus infinity to plus infinity. So please note this point, x is unrestricted, it can take anything, any value. Okay, so the curve that you are going to have will lie between these two lines, 0 to 2a, and above the 2a values and below the 0 value there will be no curve, and your curve will be anywhere over here because there is no restrictions on x. Okay, fine. Now we are going to check out the symmetry of the curve. So we will check out whether x is even or y is even. So if we replace t by minus t, we know that cos of minus t is equal to cos t, so y will remain as it is, so this will be even function. But when you replace t by minus t over here, this will give you minus t and this will also give you minus t, so x will be odd. X will be odd function and your y will be even function, and since y is even, your symmetry of the curve is about the y-axis. Okay, so here we are having the symmetry is about y-axis. Okay, now the point of intersection that we are going to find out, that is before we go to that point, we are going to check out whether the curve is passing through origin or not. So for origin, you have to find out such a value of t for which x and y both will be at the same time equal to 0. So here, for example, if you put t is equal to 0 over here, cos of 0 is 1 and y will become 0. Similarly, when you put t is equal to 0, sin 0 is 0 and x will be also equal to 0. So we are having one value of t for which x and y both are equal to 0. Therefore, curve will be passing through origin. Okay, the curve is passing through origin. Fine. Now this is the last point, special points on the curve. So before we find out the special points, we are supposed to find out the derivative dy by dx. So dy by dx is equal to what? Dy by dt upon dx by dt. Okay. Now it is equal to tan t by 2. How we are getting it is as tan t by 2. See, if you find out dy by dt, it will give you what? Derivative of 1 will be 0 and derivative of cos t will be minus sin t. So you are going to get that a into sin t into the numerator, and in the denominator you are going to get it as 1 into 1 plus cos t. Okay, so these are the derivatives of x and y, and you can write down this a sin t as a into bracket 2 sin t by 2 cos t by 2. I hope you remember this formula. Is sin 2 theta is sin 2 sin theta cos theta. Similarly, 1 plus cos 2 theta will give you 2 cos square t by 2. And here this 2 will get cancelled out. This a will get cancelled out. 1 cos will get cancelled out. And what you are going to get? You are going to get sin t by 2 upon cos t by 2. That is nothing but your tan t by 2. I hope you are getting this. So you are going to have dy by dx is equal to tan t by 2. Now we are going to find out such a values of t which will make this dy by dx is equal to either 0 or infinity. Now we know that tan 0 is 0 and tan pi by 2 is infinity. So we are getting such two values of t as 0 and pi. Okay, so we are going to put t is equal to 0 as well as we are going to put t is equal to pi. One more value that you can take is when you take t is equal to 2 pi, so it will give you tan of 2 pi upon 2, it will give you tan pi, and tan pi is also What is tan pi? Tan pi will give you 0 again. Okay, so we are going to get one table. So that table will look like this. So we are going to take t is equal to 0, pi and 2 pi, and the corresponding value of x and y will be there in the table. When you put t is equal to 0, your x will be 0, your y will be also 0. When you put x is equal t equal to pi, you are going to get x is equal to a pi, y is equal to 2a pi. When you put t is equal to 2 pi, you are going to get x is equal to 2a pi and y is equal to 0. So that values I am putting. Now when you put t is equal to 0 over here, your dy by dx is equal to 0. When you put t is equal to pi, you are going to get tan of pi by 2 is equal to infinity. When you put t is equal to 2 pi, you are going to get dy by dx is equal to 0 there. Okay, so this is the table that you are going to have. Now the very important thing is, if you remember, when you are going to have dy by dx is equal to 0, we are going to have a tangent parallel to x-axis. Remember this. So for these 2 points, we are going to get a tangent parallel to x-axis. And for whenever you are going to have dy by dx is equal to infinity, we are going to have a tangent parallel to y-axis. Okay, so let us see how the graph will look like. These are the 3 points that you are going to have. 0, 0 is first point. See, this is 0, 0. Then the second point is a pi comma 2a. This is a pi comma 2a. And this is 2a pi comma 0. That will be your next point. So it is 2a pi comma 0. Okay. Now we are getting a nature of the tangent also at this point. Okay. To draw the tangent also. So listen. At a pi comma 2a, since we are having infinity, so we are going to have a tangent parallel to y-axis. And at these 2 points, we are having 0, 0. That means we are going to have a tangent parallel to x-axis. Okay. Now since these are the tangents, how the nature of the curve over here, it will be like this, parabolic. And here also it will be parabolic. Okay. So how your curve will look like this thing. Okay. So since both are the tangents, and it will join, and the graph will look like this. And one more thing, if you look at this, we are having the symmetry is about y-axis. So whatever you are going to have on this side, the same kind of thing you are going to have on this side. Okay, so let us continue complete this curve. So your curve will look like this. Okay, so this curve is called as cycloid. Okay, so remember the name of the curve. This curve is called as cycloid. Okay, so let us go to the next curve. So we want to trace the curve x upon a raised to 2 by 3 plus y upon b raised to 2 by 3 is equal to 1. So again the same things we are going to check out: limitations, symmetry, then the origin, then we are going to find out the spatial points, and then we are going to trace the curve. Okay, but before we start with this curve, we don't have a values of x and y. So first of all, we are going to write down the values of x and y which will satisfy this equation. So here we are going to put x is equal to a cos cube t and y is equal to b sin cube t. Now this values of x and y will satisfy this equation. Okay, so either in the exam they will directly give you this, or they will give you this. If they will give you this thing, you are supposed to write on x and y in this form. Okay, fine. Now let us check out the limitations of this curve. So as we know, cos can take the value plus and minus 1. So when you take plus 1, you are going to get x is equal to a. When you take minus 1, you are going to have x is equal to minus a. Similarly, for y, again sine can take the value maximum minimum as plus 1 and minus 1. So you are going to get the values of y as minus b and plus b. So the limitations of x and y will look like minus a to a and minus b to b. Okay. Now we want to check out the symmetry of the curve. So for that we want to check out which function is even. Okay, so we know that cos of minus t is cos t, so x will be even. But here when you put sine is equal to minus t, you are going to get that this will be odd. So we are going to have the symmetry is about x-axis. But if you remember, in a symmetry we have written one more point, that when you replace t by pi minus t, and if y remains unchanged, then also we are going to say that there will be symmetric about y-axis. So if you check out over here, when you replace t by pi minus t here, so sine of pi minus t is same as sine t. So it will not change, it will be same. Okay, so we are going to say that the curve is also symmetric about y-axis. The curve is symmetric about both the axes x as well as y. Okay, so it is symmetric to both. Okay, now the next point is the point of intersection. So the important thing is to whether the curve is passing through origin or not. Okay, so here we can't find out a t for which sine and cos at the same time it will be equal to 0. That means there does not exist t which will make x and y at the same time equal to 0. Okay, because when you put t is equal to 0, your x will be 1, x will be a, and y will be 0. Okay, so it will be difficult to find out. In fact, it is not possible to find out such a t, so the curve will not be passing through origin. Okay, now the special point is dy by dx. Again you are going to find out. Again, when you differentiate this and all, you are going to get that dy by dx is equal to ab upon ab into tan t. Okay, so let us trace the curve up till what we are getting. So the limitations of y will be minus b2 plus b, that I have drawn over here, minus b2 plus b. Then the limitation for x will be plus a2 minus a2 plus a minus a2 plus a. Okay, and these are the limitations. That means the curve will be totally lies inside this. Okay, here you are going to have the curve. Okay, then since it is symmetric to both the axes, if you trace the curve over here only, okay, so whatever curve you are going to have over here, the same kind of curve you are going to have over here, and by the symmetry of x, the same thing you are going to get it over here. So it will be enough if you trace the curve in the first quadrant. This remaining part you can easily trace. Okay, now if you make a table over here, so you are going to get the values of t as 0, because when you put t is equal to 0, your tan t will be 0. When you put pi by 2, tan pi by 2 is also equal to infinity, so that will help us. Dy by dx is equal to 0 or infinity. When you put t is equal to pi, it will give you dy by dx is equal to 0. Okay, so if you look at the points are a comma 0, 0 comma b, and 0 comma minus a. Okay, so let us draw that points a comma 0. Then the next is 0 comma b, and the next is the point minus a comma 0. Okay, and if you look at the point a comma 0, at a comma 0 we are having 0. That means we are going to have a tangent parallel to x-axis, and at 0 comma b we are going to have infinity. That means we are going to have a tangent parallel to y-axis. Okay, now these are the tangents. The graph will look like this. Okay, let us join that. And by the symmetry about x-axis and y-axis, we are going to have the same kind of thing over here. Okay, so let us complete it. By the symmetry about y-axis, you are going to have this thing, and then by symmetry about x-axis, you are going to get the down part. Okay, so this is the curve that you are going to get. This curve is called as asteroid. So these are the two important curves that you are going to have. Okay, so this curve is called as asteroid. The last curve that we have seen is called as cycloid. Okay, fine. So we'll stop here today. Thanks for watching the video. Okay, in the next curve, in the next lecture, we are going to see the polar curve. Thank you everyone.